coming to this one, we are given find the value of k if k over that is equal to this. You notice that if I try rationalizing this, that's multiplying by the conjugate of this, there will be a problem because we'll have square of k down, so it will take us time. So what I will do, I'll have to change some position. I'll bring root 3 plus root 2 down and move this to that. Nothing has spoiled. We're on the right track. You know why? Because if I rationalize this, I will not have any, I will just have a constant. So it's better I do it this way. So if I rationalizing this, multiplying by the conjugate, which is now this, why this turns out to be difference of two squares. We'll repeat this. Nothing has spoiled. So the next thing now will expand. This 3 minus, okay, so we are left with k. Expand k times that is k root 3. K times this is minus k root 2. Here, remember 3 minus 2 is 1, so no need of writing it. This is now k root 3 minus 2. What do you notice? K root 3 is here, k root 3 here, minus is here, minus is here. So I have k root 2 equals 2. So the next thing is k, 2 divided by root 2. And if you notice, I can write 2 as root 2 times root 2 over root 2. So the answer is root 2. So my k is root 2. That's the value. So the next question, we are asked to evaluate this. So the next thing we'll do is just rationalize. So I'm rationalizing. I have 1 plus a plus root a multiply by 1 minus 1 plus root a minus root a. So I rationalize. See what is here is here. So I rationalize by multiplying by the conjugate. The conjugate is, okay, it should be plus. The conjugate of this, why this is now difference of two squared. Remember, I told you whenever you rationalize anything that has plus minus, it will always turn to difference of two terms. Always turns to difference of two squared. So this is 1 plus root a plus root a all squared. That is a perfect square. That is the same. Why this is 1 plus a square of that, square cancels square root, so minus a. So what we have here is just expansion of this, which is square of this is 1 plus a, square of this is a, y 2 times this times that is plus 2 times 1 plus a times a over 1. So no need of writing over 1. So a plus a is 2a. Why this 2? You can expand the bracket inside, which is a plus a squared. So that's my answer. The answer is C. So the answer is C. So the next question, we are asked to evaluate. We are asked to evaluate this. So we need to solve this fast. There is a way I will solve this. It will not take us time. There is one elementary identity that states that if you have a plus b squared plus a minus b squared, the answer is always, since it's plus, is always a 2 times a squared plus b squared. But if it's a minus, that's the negative of that, is now 4ab. So that's what I will use to solve this very, very fast. So the next thing is just our numerator. We'll do our LCM. So the LCM is root 5 plus root 3 times root 5 minus root 3. That's our LCM. Why the numerator is now root 5 minus root 3 times that square plus root 5 plus root 3 all squared. So this turns out to be difference of two squares. Why this? Remember, they are the same, though this started, but addition is commutative. So I can write it as 2 brackets root 5 square plus root 3 square. So 5 minus 3 is 2. So 2 to that 2. So we are left with 5 plus 3, which is 8. So that's our answer. Check our solution. 2 brackets root a squared. So root 5 squared is 5. Root 3 squared is 3. So 5 plus 3 is 8. Why the 2 here? Reduce this root 2. So that's the fastest way to solve this question. So the next question, we are given almost the same thing, just the negative one. So applying, using that negative formula, the first thing we need to do is find our LCM, which is that times that. Why this one turns out to be root this all squared minus root 3 plus root 5 plus root 3 all squared. You notice that here is not commutative. This turns out to be 5 squared. That's root 5 squared 5. Root 3 squared 3. So 5 minus 3 is 2. So why this one turns out, remember, check this. The positive plus started. Why this one? But here, this is negative. So meaning the opposite. So I'm saying it must be minus 4 times root 5 times root 3. Just the opposite. 4 into, so we have minus 2. Root 5 times root 3 is root 15. I guess this is the fastest way to solve this question. You don't need to waste your time. So the next question seems the second to the last question, or third to the last. We are given if x plus y equals 5 and xy equals 1, where x is less than y. So x must be less than y. So we're then asked to evaluate roots x minus. So we are given this. So the next thing we do is we need to rationalize. So multiplying by the conjugate of the denominator, which is root x minus root y. Why this turns out to be difference of two squared. So the next thing is this expansion of perfect square. Expansion of perfect. So why this x minus y? So the next thing we'll do, root x squared is x, root 5 squared is 5, is root y squared is y. 2 times this is now minus 2 times root x y, because x times y is xy, over x minus y. But they told us that x plus y is 5. So I have 5 minus 2, because this is 1. So square root of 1 is 1. So we have 3 over x minus y. So, but we don't know the value. Or looking at the option, there is nothing like that. So we need to get the value of x minus y from the identity I gave you before. I told you that a plus b squared minus a minus b squared gave us 4ab. So remember, it's like x minus y here. So which implies that if I make a minus b the subject of formula, is now a plus b all squared, check it, minus 4ab all in square root, check. This goes over to this to be positive. This comes here to be negative. But you need to be, square root is always plus minus, because they told us something. X is less than y. So we are using the negative aspect. So therefore we have 3 over x minus y is now 3 over, this is like x minus y, so which is now minus square root a plus b, which is x plus y squared minus 4xy. So we have minus 3 over square root of, so x plus y is 5. 5 squared is 25. So I have square root of So I have square root of 25 minus 1. 1 times 4, xy is 1. So that's what we have. So I have square root of 21. So looking at the option again, there is nothing like that. But we know that we can write 3 as root 3 times root 3. And I can write 21 as root 3 times root 7. So the answer is now minus root 3 over root 7. Check it. Root 3 off. So that's our answer is D. So that's our answer. Our answer is D. So the next question, we are asked to solve this. We are asked, given that an expression, we are asked to solve it. So I think the best way is to assign it to any variable of your choice. So let root 2 plus root 3 minus 2 minus root 3 be equal to x. So the next thing, the first thing, since I have square root in here, we need to square. So squaring both sides. So we square both sides now. We have 2 plus root 3 minus square root 2 minus root 3 all squared equals x squared. So that's a good way. So we expand using our perfect square, that's a plus b or a minus b all square. So we have 2 plus root 3, that's the square of this, plus 2 minus root 3. Just I added this. I'm saying that a plus b all squared is now a squared plus 2ab plus b squared. So I added this and this first. Square of this is this. Square of this is this. So that's why finally this is minus. So if you have minus here, we have minus. So I have minus 2 times 2 plus root 3 times 2 minus root 3 equal to x squared. So the next thing is to add. 2 plus 2 is 4. This, okay, 2 plus 2 is 4. Root 3 minus root 3 is gone, so we are left with minus 2. Check this, I can bring the 2 together. Yes, I've brought the 2 together, and inside we have difference of 2 squares. So I can write this as 2 squared minus root 3 squared equals x squared. So we have 4 minus 2. 4 minus 3 is 1, so we have 2 equals x squared. 4 minus 2 is 2. So my x is root 2. So that's the answer. That's the best approach. The next question, we are asked if that plus that equals that. We are asked to find b. Again, since we have square root, we need to square both sides. So squaring both sides, we have 6 minus root b all squared. Sorry, plus root, this square root 6 plus root b. We are squaring both sides equal to root 14 squared. So remember expansion here, this is 6 minus root b plus 6 plus root b. So I just added, remember the other previous work, plus 2 times 6 minus root b, 6 plus root b. Okay, equals 14. So 6 plus 6 is 12. Root b plus root b minus root b plus root b is gone. So remaining 2 here. Difference of 2 squared, which is 6 squared minus root b squared equal to 14. So here we have 2. I have to collect like them. This is 36 minus b, which is now 14 minus 2, 12. 14, I move 12 to the other side. So I have 2 here, and I have 2 root 36 minus b. So I have 1 here. I have 36 minus b, all in square roots. So this is now 36 minus b, all 1 squared is that. So finally, b is 36 minus 1, which is 35 for us. So that's our answer. So I think there is no other question. So once you're able to solve the questions here, at least you can attempt 98% of the questions in solid or radical. So have a nice day. Any question, you can comment or send me a message. Thanks.